Welcome to solverfy.
We're now asked to use the polar second moment of area of the isosceles triangle from problem 28. Show that the centroidal polar second moment of area of a circular area of radius r is 4r squared, or pi r squared over 2. Okay, so we know what our radius, our polar area moment is for a regular isosceles triangle, for a general isosceles triangle. So we can think about how this thing, as we shrink this distance here, okay, and then we kind of add them all up. As we shrink it and add them all up, we get something closer and closer to a circle. And as this length goes to 0, and the number of wedges we add up, basically it goes to infinity, and then that we get a full circle. So we can think about a differential element here. So call it, this is r. So if this is r here, okay, and then this is r d theta, where this is theta, okay, and we'll call that's equal to b, which was this distance here. So we need to substitute r d theta in for b for this differential length here, given a differential wedge angle. And then as theta gets small, r approaches h. So we can use the approximation that r is h. If we plug in, we get that the polar second moment of this differential element wedge is dir, and then if we plug everything in, we get that this is 1 over 48 hr d theta times r squared d theta squared plus 12 h squared. And now d theta squared is a higher ordered term, so we can drop that out. This is very, very much smaller than this, so this goes away. We know h is roughly r, so we can plug that in, and again, as theta gets small, h goes to r, and we wind up with this expression here. Okay, so we get our differential polar area moment is 1/4 h cubed r d theta, or 1/4 r the fourth d theta. And now we can integrate over all of these wedges, all of these angles, d thetas. And when we do that, that's just a simple integral, because nothing here depends on theta. So we go from 0 to 2 pi, and we get that that is, oops, I have a 4 in here instead of a 2, obviously. That is pi over 2 r to the 4th, okay, because we go from 0 to 2 pi, so this gets multiplied by 2 pi, so we get pi over 2 r to the 4th.